Now we're going to finish up our Chapter 1 with examining the distributions of quantitative data. We're going to look at the patterns from graphs, deviations from the patterns, and we're going to look at the shape, the center of data, and the spread. And then we're also going to see what we mean by things called outliers. Identifying shapes of distributions. That's a way that we can describe a distribution. One way is by its shape. Now, there are some common shapes that distributions take. We have uniform, symmetric, bell-shaped, or other symmetric shapes, asymmetric, right-skewed or left-skewed, unimodal or bimodal, and there's multimodal also. So there's different shapes, but these are the ones that we're going to take a look at. Here's the uniform distribution. It is uniform. It's like a histogram that's completely flat. No bar is greater than the other bar. Therefore, it's called uniform. Now we're looking at a bell-shaped distribution, and we can see that it has a high point in the center, and then it tapers off on both ends. And if we were to put a line through the center of it, the one half would look like or close to a mirror image of the other half. So here's a nice bell-shaped graph, and then we have a mound-shaped graph next. Both of those would be considered symmetric because, again, we could draw a line in the center of both of them, and one side would be the mirror reflection of the other side. That's what we mean by symmetry. Now we're going to take a look at data that's skewed. The data that you're looking at right now is skewed right. Another way to say that is that the data tapers off to the right. Therefore, we call it skewed right. Let's take a look at a distribution that's skewed left. As you can see, the data tapers off to the left. Therefore, we call it skewed left. So as we saw in the bell-shaped, there's where the center of our distribution lies. It's very nice. It's right there smack in the center. Now, with the skewed distribution, if you looked from the range where the middle part is not necessarily the center of our distribution. The center of our distribution is further left because the data tapers off to the right. Same would apply for asymmetric or a skewed left distribution. Again, if we look at the range of data values, there would kind of be the middle part right there. But where the most of our data lies, because of the height of our distribution, is a little bit to the right of it. Because our data is tapering off to the left. That's a skewed left distribution. And lastly, we're going to talk about time plots. Time plots are extremely useful. Lots of time you can use it to track your investments. You can look at how things are going over a period of time. So these are time plots. So time is our horizontal axis. In other words, time will move forward and we'll see a trend happening as time progresses. So here we're looking at the price of a particular stock, and it's over time from March until March 03 to February 05. And you can see it steadily increases for the most part up to January 04, but there are little dips in there. But on average, it has increased. Then it looks like it decreased, starts to increase, decrease, and then starts to level off toward the end of the 04 into 05 period. So you can read these and get what's happening over a long period of time. In other words, a trend that may be occurring or not occurring. You can compare two things in one of the time plots, and so in other words, we're looking at the average tuition and fees of a private school as compared to a public school from the year 1970 to the year 2000. So you can get a lot of useful information off these time series graphs. So remember, with our time plots, we have the time as our horizontal axis, and whatever it is that we're measuring will be on our vertical axis. And remember, always have good titles. Now, our very last topic to discuss is things called outliers. They're extreme values that fall outside the overall pattern of whatever distribution you're looking at. And there's lots of reasons for these errors. It could happen naturally, or you could have a recording error, or someone could have actually made a mistake when they were measuring or taking the initial measurements for that particular variable. Observational unit may be fundamentally different. So we have to try our best to figure out why these outliers occur, because they're very important to how we're going to analyze our data. We can't just pretend they're not there. We have to figure out what's going on and then deal with it. So outliers, if you had a histogram, an outlier would land outside of the general pattern of the histogram, dot plot, stem plot, whatever plot that you made. We've now concluded Chapter 1.